Hey everyone, it's been a while. I did some refactoring of the code off stream. I'm going to show you what I did today. And then we're going to start testing it. Like all of the refactoring I did is currently untested, and we're going to see what we can do about that. All right. MATLAB's loading now. So what did I do? I created MRI Recon. And what's the refactoring here? Well, I no longer do the thing where I set up the functions so that either PDHC or FISTA solves the problem. For each option of inputs for whatever problem I'm going to solve, right there, I set up the function and solve the problem, reconstruct the image. I think this is cleaner because it was becoming difficult to figure out whatever post-processing was needed after the optimization to reconstruct the image. I was basically having to set up this same set of conditions before and after. You can see what these conditions are. If the number of coils is greater than 1, if the number of sensitivity maps is greater than 0, if the support is supplied, and if the EPS support is greater than 0, if EPS data is greater than 0. All right, so that's what's happening here. As I said, none of this is tested, and that's going to change now. So we're going to do just the simplest thing first. Let's see if it makes anything at all. Here's loading in the data, sample masks, making the samples, and here's where the image reconstruction starts. Old recon methods. I guess we could keep that one. Okay. So the simplest thing to do would be to just supply K data, or rather K samples. Figure IM show scale absolute image. MRI Recon, because it is called MRI Recon. And we've got a bug. Well, that is that. Oh, so what's happening here? This is all happening because there are checks in here, and do checks is set, and even if it weren't, all of these things, all of these functions are going to get created. See, so just getting this to run is going to be a little bit difficult, it seems. Input parameter. Huh? Input parser. Forgot the name of the thing. Okay. That is the fully sampled reconstruction, and that is a good quality image. We got it to do something. We got this new refactor code, which has a ton of lines in it. Not a ton, maybe a pound or two of lines. We got it to run. Now look, lots of these options, are not, I don't yet have implementations for these things. That's fine. We're just going to get something working. And we might not do all of these before the end of the project. Like I might just implement the ones I need to show that spirit regularization is useful. That's where I'm at. Okay. Now, and the next question is, was do checks set? Because, so it was not set. Let's do checks. And let's see what breaks. Okay. Do I have an SK data? Looks like I don't. An image. Looks like I also don't have an image. Wow, that was much easier than I expected. And whatever checks ran, they passed. Okay, now, some of these checks are not running because, for example, the sensitivity maps are not supplied. So I can't do the checks involving the sensitivity maps. Guess what we're going to do now? Well, you're going to check sensitivity maps. Okay. If I remember right, we've got two sets of sensitivity maps. Okay, so something broke. Oh, I see. This is still running. So before I was making things more complicated higher so that you know, the more experimental one would run first. I wouldn't have to go through all the rest. I guess I'll keep doing that. All right, so there's a problem. LSQR failed. I don't want the LSQR. I want this. Where is LSQR called? Oh, here. Okay, why did it fail? Image not is way, way, way too large. Where did image not come from? Okay, image not just does the apply F inverse. So image not is equal to MRI recon roamer image not. Okay, that's about right. Got aliasing, fully sampled center region. That looks good. LSQR is running. The additional adjoint checks seem to have passed. And the result is terrible, which we expect because the undersampling is so bad, right? What is the undersampling for sample mask? 1 to 3, yeah, every third. Now, I thought we had gotten good results with that before, so let's check. What happens in model-based recon if you don't supply the S maps? Does it estimate them? Oh, okay. If you supply multi-coil data, it assumes that you're estimating the S maps. Okay. So it turns out there's a long history of research involving the support in the reconstruction. Why aren't people using it? Like, I don't know anybody that uses the support clinically. They may use the fact, oops. Okay, so one's different than the other. That's a little strange. Is it just because one ran longer than the other? They may use the fact that the image is a subset, the support is a subset of the field of view, but they do not use a known support, which is easy to get, and I don't understand why it isn't being used. Like that should just be used. There's no reason not to. Okay, so LSQR, how many iterations does this thing go for? Is it doing LSQR? Should be. It's going for 250 and MRI recon over here. And max iter. It's 1,000. So what happens if I change this to 1,000? Was that the difference? That looks darker. That was the difference. Okay, problem solved. Everything's okay. We'll send that back to 250 and we'll delete that. And it looks like MRI recon with sensitivity maps is working. What to do next? Compressed sensing. When is compressed sensing true? Okay, so I don't know if I've implemented lambda. Let's find out. Looks like I did. Whoa! Crashed. Verbose is not a recognized function or variable. Let's change that, shall we? Do I want verbose to be true or false? I guess I want it to be true. Still broken. Inputs to dot P must have the same number of elements. I think I know the issue. Guess what? Guess the size of image not. Okay. That looks terrible. Looks like it's doing something. That looks much better. Oh, you know why it looks terrible? Because I didn't use the compressed sensing samples. That looks great. I'm quite surprised how well these codes are working. Okay, Now, what comes next? Now, I guess supply EPS data. We're not going to do it with the support. Whoa. Wait, this is supposed to be CS equals true. Number of coils greater than 1. Number of sensitivity maps is greater than 0. Support. So this should actually, that seems wrong, doesn't it? This should be surely that's not what. Oh. But this is always CS. Oh. Okay, never mind. This else for is the else for the if CS equals true. So if CS equals true, then we're in here in coils S maps, numerical support is not greater than 0, so we go into this else. OSI is going to be true because we're using the Debichet 4 wavelet transform. And here we are with if num L lambda is greater than 0. Okay, so this is where we should be. And if not, then we use EPS data. Okay, this is what I wanted. And EPS data is an estimate is the variance of the noise or the error, a variance of the error. So we're going to pass in noise var. That crashed. Not enough input arguments. Line 465. Huh. Okay. X psi b alpha t. What is alpha? Okay. B alpha is the one right before t. This is an orthogonal transformation. OSI equals true. So alpha is 1. All right. Nope. Okay. This is running. And I've lost the metrics and such. Such is life. Okay, there's metrics around here somewhere. Nope. It's not even defined, so what happens if you pass in a variable that doesn't exist? Huh. Strange. I think I'd like the metrics. Excuse me. All right, we're 20 minutes in. Let's see. Where is this DB stack? 470. You know, I can make the wavelet transform faster. It's one of those things, as soon as I do it, I'm going to say, why didn't I do that before? Metrics, metric names, okay. All right. This is going for 1,000 iterations. This is astoundingly slow. But we know that unless you go for 1,000 iterations, you don't get a decent result out. So there you have it. Should probably create these metrics after these things are made, huh? We need a there we go. If a lot of the time is being spent in the wavelet transform, maybe it's time to fix the wavelet transform. You're joking. You know what I forgot? Image none. Let's try again. see that we're doing this radius. So this is not going to be a major change, okay? But a major efficiency. We're doing this radius calculation several times. We could store it. We're also doing it down here. Okay. Now we have to wait for 1,000 iterations again, but oh, we're printing every 10, so that's nice. And we got these metrics, and that's just kind of nice to see, isn't it? Okay. Where else was there a recon roamer? Do we have sensitivity maps here? Yes. So that at least prevents us from having to calculate sensitivity maps within recon roamer. It's a fast calculation relatively, but no reason to do it if we don't have to. I should really call this like coil recon 0. Then image 0 is going to be MRI recon roamer coil images 0 S maps. And then hopefully recon roamer is smart enough that if you supply S maps but it's empty, yep, then it calculates something. So that should just work. So now let's go back to image 0. Oh. I just broke the code. And I can fix that. Oh, okay. Here, like this. If n coils is greater than 0, and n coils is greater than 1, and so this will be this. And now everything's okay. Oh, wait, is it? I don't think it is actually. I think that's a bug. Let's see what this did. That's a high quality image, folks. So we've got good stuff happening. Okay, the issue is psi and psi. I think you need to apply it to different things in different places. See, here it would be applied to N0. Image 0, I mean. Okay, so then N psi should just be I guess we'll have N psi coils equals numl psi coil images 0. Okay. Okay. This code works. What I'm going to do now is just go through an example. Like we're just going to add a new, one of these, whatever's happening. I guess we'll add this one. Oh, no, this one looks complicated. We might have to use PD3O, which means we have to implement PD3O. We don't have to use PD3O, but we might use PD3O for this. The reason is that this is differentiable. This has a simple proximal operator when no psi is true. And this has a simple, actually that also has a simple proximal operator. So never mind, we're going to do this now. Okay. So F equals apply MFS. Oh, no. Can we use, if OSI is true, OSI happens in here. Okay. If OSI equals true, else end. Okay. So F is going to equal to 0.5. I think we can use Pfister for this. Times norm, apply MFS, minus B squared grad F is equal to apply MFS minus ST FT MT B. Okay, now G. Oh, no, still okay. Still okay. G1 is equal to prox composition affine prox L1 complex in, shouldn't have done that, okay, psi T. Prox G1 is equal to, oh, lambda times T, okay. Well now, but that's the prox G1. G1 is equal to in lambda times norm psi x. I'll turn this into a column vector. Okay. And here's the proximal operator. G2 is equal to, this isn't right. So this should be squared and C minus 1. C in 2 Frobenius divided by NC minus 1 indicator function zero EPS support. Is this anywhere else? Yes. This is, okay, this is NC. So in this function, I put PC here, but I shouldn't need to. And support equals 1 is equal to, oh, what I need to do is like this. Out equals in, and then out. And you cannot have multiple lines in an anonymous function. MATLAB, multiple lines in an anonymous function. Wow. Okay, there's like a meta programming in MATLAB. Won't be doing that. We'll definitely not be doing that. Okay. I think I faced this already. We're at line 440, okay? Project outside. Look at that. Okay. Now we use Vista. Okay, so this was called fgrad. Oh, no, forgot about proxg, didn't I? Okay. No idea what T naught should be. Proxg is equal to at nt. Well, proxg1 in from 1 to NB, proxg2 from end NB plus 1 to end. What does proxg1 return? I guess it returns something of the same size. Excuse me. I think I need to make it a column vector. So did I end up fixing that thing with it? Yep, I did. Okay. Where on earth was I? I think it was right here. I think that works. And so one day we'll test it, but not today. So that now you see, like, this is the sort of routine that happens for every combination of conditions that are of inputs that are supplied to this code. We have some of these errors not yet implemented. I guess I could put one right there. Just trying to make sure. This has a simple proximal operator, and this has a simple proximal operator. So G is equal, oh, shoot. No, I cannot do this. Yep, can't do it. So what? You have something that is differentiable, something with one simple proximal operator, and a second thing with a simple proximal operator. Okay, so that was a waste of time. Could use PD30 here. Yeah. Thank you, MATLAB. Guess I'll just put that there. Could use PD30 based on whether or not OSI is true. All right, so that was a waste of time. That's all we're going to do with that today. What else have we got? Oh, what happens if OSI is false? I'm not going to check it because that's not what we're working on. Okay. Now what? Just put this one down here, I guess. I can always move it back up if I want to see the true image. Yes, okay. Never mind. I think what I'm going to do now is Spirit Reg. Here's where the code did not work out as nicely as I wanted. Because rather than creating like a different implementation for each pair of each combination of inputs, I wanted to like be able to create G Spirit Reg, G compress sensing, whatever, G lambda, and then use FIS or PhD to solve them based on, to concatenate the proximal operators into a single proximal operator and then run. But instead, now it seems like what I have to do is now one way to simplify this code is like maybe if n coils equals 1, I just always use a sensitivity map of all ones, which adds computation, but not much relatively. And then I could call the same code over and over again. This is pretty tough. All right. If n coils equals 1, sensitivity maps. Yeah, because I'm also got this going as sensitivity maps. If you don't supply sensitivity maps, you could do joint sparsity is my idea. We'll see if I ever use that. Okay, we're going to add spirit regularization. We already have W size here. We don't have it here. Positive. I have to leave. I have a meeting at noon. All right. There's this function. I remember a support function, and we're just going to steal that. Let's add that down here. It's very warm in my office. Let's see where W size gets used. Oh. We're also going to need SACR. Okay. Cannot perform spirit regularization with only one coil. Okay. You must supply SACR if you supply W size. Did I not do this? If you supply W size and the number of coils, this should be equals 1, right? How did this ever work? Because this is, when you supply W size, then you're doing spirit regularization. Okay. Now what? Going back to where W size is used. times W. What is this doing? I think it's like preparing. Gamma. What was gamma? We're going to call gamma EPS Spirit Reg, EPS Spirit. Wait, surely gamma's not passed in. You can pass it in, okay? I'm trusting my past self. I don't remember this stuff well enough. I will eventually, and then we can decide for ourselves whether or not to keep EPS gamma as an input. EPS gamma? No. EPS Spirit. So let's call that EPS Spirit Reg. All right. This does parallel processing, so let's get ready to do that. We're going to set up a par pool. Okay. Where does flip W get used? You make a function apply W. Okay. Apply F, apply W. Oh, nope. Apply FS, LMN, PS. Ooh. Oh, because it's default size. So what's it doing there? Oh, because all of these are apply. Okay, that makes sense. Okay, so now we've got apply W. W. Apply W minus I. All right. We'll just keep going. Apply W minus IFS. All right. And we've got a concat. Oh my goodness. Let's add a check. S image 0. Oh goodness. I didn't test any of the support stuff. All right, maybe that's for another stream. Let's see if we could get this up and running. Okay. Variable might be unused. What are you talking about? I don't know. Okay. There was a concat somewhere. MFS, WMIFS, MFSI, WMIFS. Which one do I need? I guess we're about to find out. Okay. These are all the due checks. Should I check WMI? Let's check WMI as well. Oh, you know what? I think you can do spirit regularization without sensitivity maps. What does it say? Variable might be used before it's defined. Somewhat like, what? I'm so confused. This, okay. Okay. I see. Oh, of course. Okay. Working on spirit regularization over here, people. Oh, so yeah, I mean, that actually ran. Nothing I added broke anything. It's a check, not much of one, but a check. Yeah, see, this is me trying to do it the other way. It should be an image minus 1. Oh, changing it in the wrong spot. Okay. Prox G spirit reg. Okay, this is going to be a lot simpler. Because I'm just going to use project onto ball. Huh. That's interesting. We've come a long way since a comment like that, haven't we? Okay. seems to be what the sort of thing we're doing. All right. Do I have a W size anywhere in here? Doesn't look like that I do. Okay. Five, 1, 4. So where's the else? So we're going to do it here. If num_l W size is greater than 0, do spirit regularization. Do I have a similar thing without the support? I guess this is it. So we're just going to get rid of that. MFS, WMIFS. So concat WMFS and WMIFS. Concat, where are you at? MFS, WMIFS. Okay. This is B. And in Spirit Reg. What on earth is that? NK data. NK data. Do I have? I guess I don't have an NK data. GDC. So this one we have 0.5 times. I wish. What is GDC? This is when I thought I could do that thing where I just define functions and use the proximal operators, the gradients or whatever as they come along. Oh. Okay. So that's GDC. And from 1 to N1 plus G Spirit Reg H. G Spirit Reg. It's an indicator function. Minimize 1/2 L2 norm M at S X minus B plus, let's say, subject to like I want to make this an image minus 1. Okay. That can't be right. Okay. It's going to be EPS Spirit Reg. Call this G1. G is equal to at in G1 of in plus G2 of in. I'm writing differently now than when I created Recon Spirit Reg. One, two, and one. And 1 plus 1 and 2. Should be G2. Oh. There's a lot going on. I'm going to call this Spirit Reg, not G Spirit Reg. Why does that matter? This is because it's not being used. Why does that matter? Huh. Norms equal to LP norms X squared. So reshape X and coils to 1. L equals 0 if max norms call it X norms. Greater than, if any of X norms is greater than divided by image minus 1 is greater than EPS spirit reg out equals infinity. End. Think that works? G spirit, okay. Spirit reg. Good. Prox GDC. Prox G1 is equal to what's prox spirit reg? Huh. This is doing a projection. I'm going to call this prox spirit reg. What is this doing? Well, these are vectorized functions. What is project doing there? Put in the wrong spot. All right. Concatenating functions. Project should go here. Yep, okay, there we go. Spirit reg. Because that doesn't, this is a scalar, so that doesn't need to be a point divided. Worried about the order of operations. I want to make sure this division happens before the comparison. Out equals zeros. So I would write this now as out coil index is equal to project onto a ball in coil index rad ball like that. And then what's the radius of the ball? Rad ball is equal to square root EPS spirit reg coil index times n image minus 1. Ooh. You want that as a column vector, do you? Call this in. Outer loop index, coil index is set inside a nested function. Oh, I see. Coil index is being used outside of this function, so you don't want to be changing it inside. Okay, that was the issue there. Yeah, I think I could vectorize this loop, but I am not going to. And that's where we are. Okay. Prox G1, okay. Prox G is equal to at in T reshape. Well, I don't know. Prox, what does Prox G1 do? L2 squared shrinks it. I think it's going to be fine. Oh, Prox G, oh, it should have been Prox G1. G2 in from N1 plus 1 to N2. Okay, PDHG, line search. F is empty. It's one of those. Trick 1. This is interesting. Does G have a simple, oh, it only does, wait, does G have a simple proximal operator? I think it does. I don't mean G, I mean this. Does the indicator function for that have a simple proximal operator? The answer is yes, it does. What does apply A? W minus I? Oh, what is this W minus I business? Huh. W minus I FS. It's like this evaluated for the Seath coil. Okay? So we have MFS and WMIFS. Okay, so now it's much tougher. Now this thing does not have the indicator function for this thing does not have a simple proximal operator, and we're back to this. Great. Almost time to call it a day. Let's see if we could just get to the point where we're actually running this thing. Metric 1, the objective. We'll just call it G1. We don't even need that. And what about the violation? WMIFS. WMIFS in See, the thing is, since I did this for each coil independently, this gets much tougher. Is eSpirit Reg EPS Spirit Reg a scalar? No, it's not. Okay. So then I think I need to make this metric up here. Function O equals metric spirit reg violation in and or C equals 1 to n coils and IFS in if norm out equal okay, so out equals max violations equals zeros coils 1. And if the norm I did this wrong. Minus square root EPS spirit reg times n image minus 1. Rad ball spirit reg is equal to if num w size greater than 0, should call this rad balls. Rad balls. Okay. Radius of the balls of spirit regularization. Metric spirit regularization. So now I can do the same thing here. Minus that. I don't have to keep replicating the code. Okay. Metric 2 is equal to matrix is equal to that. Does this have any chance of working? I would say no. I would say no. Let's see where it breaks. Oh. ACR. That's an easy fix. Still going. Let's supply SACR if you supply W size. Okay. Let's do that. Huh. Got past the checks. What? The title is wrong. And this looks bad, but it ran. However, I'm getting the feeling it didn't do what I wanted it to do, actually. Let's see what it did. That looks a lot like a least squares answer to me. Oh, we're going to skip past all these checks. This is in the wrong spot. Because this is all for if compressed sensing. And right now I'm just implementing spirit regularization without anything else. So if coils, if ends, if support no. So here, if W size is greater, if num L W size is greater than 0, otherwise, all right, else, and okay. All right, we're here and we crashed. Incompatible sizes, G1. Huh, MFS. MFS definitely outputs B and B. Stuck. And it's time to go. Well, that's where we'll pick up when we leave off, when we pick up again. We'll pick up where we leave off when we pick up again. I don't know. All right, everyone. I'll see you guys later.